reviewer estimates that the probability that he receives a delivery of books to review on any one weekday is zero point 0.1. The first weekday in September on which he receives a delivery of books to review is the Xth weekday of September. Okay, state an assumption needed for X to be well modeled by geometric distribution. Okay, remember, for a geometric distribution, there are certain conditions. Okay, one of the condition is it has to be an independent value. Okay, the probability distribution are very independent, meaning it doesn't influence one another. Okay, so the probability distribution is an independent event. Okay, it's an independent event, so it doesn't influence the if the review probability of reviewing today will not what you call influence the next day, which is tomorrow. Okay, so each probability doesn't influence, so you can even write that. Okay, the probability doesn't influence the outcome. Okay, some questions you'll have that in probability we have seen when the counter is replaced. Okay, when the counter is replaced you have a different probability. When the counter is not replaced you have a different probability. So you can talk about this since it's only 1 mark. Okay, question 2. Find the probability when X equals to 11. Okay, the question here is a book reviewer estimates that the probability that he receives a delivery to review the book in one weekday is 0.1. Okay, so on weekday, I don't know when is the weekday. Okay, on one weekday is 0.1. So what is the probability of him getting reviewed on the 11th day? Okay, on the 11th day. So let's use the formula. Okay, again, the formula is P X equals to R, and this is geometrically distributed. Okay, I'm not going to write each and every time, so but you guys, I think at this stage, R minus 1 multiplied by P. So Q to review is 0.1, not to review is 0.9. Okay, and this is 11th, X equals to 11, so it should be 11 minus 1 multiplied by P, which is 0.1. So from here you get an answer 0.9 times by to the power of 10 times by 0.1, and your answer is 0.034868. Okay, that's part 2. Part 3, let's figure that out. Okay, for part 3, find probability when X is less than or equal to 8. X is less than or equal to 8. Okay, so meaning is getting reviewed on the first day, second day, third day, all the way to the 8th day. Okay, how does that happen? Okay, so probability, either you can do what is the probability for one individual day, x1, x2 and x3 all the way to x8, and then add them, or what you can do, you can find what is the probability of reviewing for the first time when it's greater than or equal to 9. Okay, greater than or equal to 9, meaning you are not reviewing on first day, second day, all the way to the 8th day, but your very first review that you're getting is on the 9th day onwards. That's what it means, X is greater than 9. So to find this, we know anything greater than 9, your very first day, from 9th day onwards, so meaning you are not reviewing on first day all the way to the 8th day, so you are not reviewing. So For not reviewing, the formula is, we know, q to the power of r. Okay, q to the power of r. So what is r over here? Sorry, q to the power of r minus 1. Okay, not r, it's r minus 1. So to do this, oops, okay, so in this question it's q to the power r minus 1. So if it's why r minus 1? Okay, you gotta understand this. The very first review that he's doing is on the 9th day. Okay, n onwards, he's not reviewing before that. Okay, let's go to the question later. Let's understand this first. Okay, he's not reviewing on the first day, second day, third day, all the way to the 8th day, but he's reviewing from 9th onwards. So this is same as not. So what he's been doing on the first one all the way to 8 is not reviewing. So if it's not reviewing, so it has to be q to the power of how many days? It's 8 days. So q is 0.9 to the power of 8. Okay, 0.9 to the power of 8. Okay, so this is if he's not reviewing 1 to 8. Okay, not reviewing. What is the complement of that? What is the complement of that? Complement of not reviewing 1 to 8 meaning is reviewing 1 to 8, right? So to find that, now we go to the question. So is reviewing every day all the way from 1 to 8. So meaning complement of 1 minus q to the power of r minus 1 will give you your answer 1 minus 0.9 to the power of 8, which is 0.5695, and this is 2 dp. Okay, next question. Okay, next question. Okay, find the variance of x. Okay, find the variance of x. Okay, what is variance? So the formula for variance is given as, okay, VAR x equals to q over p square. Okay, q over p square. What is q? We already know, 0.9, and p is 0.1. Square that and your answer is 90. And finally, one more question. Give a reason why a geometric distribution might not be an appropriate model for the first weekday in a calendar year on which the reviewer receives a delivery of books to review. Okay, why do you, the question says why it might not be a geometric distribution. Okay, why I can't use an appropriate model to find the probability. There are others. Okay, we know discrete random variables, we have binomial, we have Poisson, and so on. But why geometry will not be suitable for to review is because, okay, not some days there are holidays, some months we have holidays in a weekday, within weekdays. Okay, if the weekdays, then you might not get any book reviewed on the next day. Okay, some months you have, like in the UK they have bank holidays, so these holidays will influence the reviewing of books. So you can write that. Okay, you can write that. So some months the reviewer, okay, might receive less books, okay, due to holidays, or at present we have a situation called COVID-19, and situation like this, you might not get books delivered, or you can say any unforeseen uh, situations. Okay, so there are various reasons. So one of it is about holidays. some weekend you have a long weekend, so that's good enough. Anything that's sensible, because how much marks are, it's only 1 mark, so anything that's sensible should suffice. Okay.